Fuses provide an extremely fast response during overcurrent events, helping prevent thermal runaway, equipment damage, and cascading failures. Because they operate through the physical mechanism of the element melting inside, with no moving parts or reliance on software, they remain highly reliable even in harsh operating environments. Modern energy storage fuses are designed for a balance of efficiency, sensitivity, and fault clearing power. They're engineered for very low watts loss and a high DC breaking capacity, up to 250 kA or more at 1500 volts DC, enabling them to safely interrupt the extremely large fault currents that occur in battery systems. At the same time, their low minimum breaking current ensures reliable protection even during smaller scale fault conditions. These specialised DC fuses in ABAT and GBAT utilisation categories are engineered specifically for renewable energy and battery applications. Energy storage systems vary enormously in size and power requirements, from small residential battery packs to multi-megawatt grid storage facilities. Fuses are available in a broad range of voltage and current ratings, allowing them to scale easily across different applications. Their modular nature also allows for easy replication of protection across multiple modules and racks. Fuses deliver a high level of protection at a relatively low cost, making them an efficient safety investment for manufacturers and operators. They help reduce the risk of catastrophic battery damage, inverter failure, and downtime that could otherwise lead to expensive repairs or lost revenue. Even after the fuse is operated, swapping in a fresh fuse is simpler and quicker than changing out damaged hardwired components. Their compact design also minimises installation space and simplifies system architecture, helping reduce overall system costs.